Okay. I'm still admitting people into the lobby. So again, we'll just wait at least another 30 seconds.
All right, we're getting closer to 60.
You called it.
We'll see. Yeah, maybe it'll get all the way up to 100, but I doubt it. Not with the holidays. I think this is pretty good attendance for the holiday time. Hi, Sutapa. Hi, Valeria.
Hi, Helene.
Hi.
Morning.
Good morning, Helene and everybody.
Hi.
Morning, Valerie.
Morning.
Okay, I think we should just get started there. Okay, good morning, everyone. For those who don't know me, I'm Brandy Chapman. I'm the Innovation Coordinator under the Bureau of Research, and we manage the activities of the STIC for DOT. So thank you for joining us today for the fourth quarterly meeting of 2022. You're welcome to turn your cameras on and show your faces. Just please mute yourself unless you're speaking. And we'll be monitoring the chat. If you have any questions along the way, feel free to put them in there. So now to kick things off, I'd like to welcome our Assistant Commissioner, Mike Russo.
So good morning, everybody, and welcome to our holiday version of the 2022 fourth quarter New Jersey STIC Council meeting. As we were saying a few minutes ago, I realize this is a very hectic time of the year, and I appreciate everybody finding the time to join us here today. I would also like to welcome NJDOT Chief of Staff Justin Braz. Today's his first STIC meeting, so Justin, thank you for being able to join us. And before we get into today's agenda, I would like to make a few announcements regarding STIC and Everyday Counts. I gotta make sure I do this in the right order and match the photos. So first, I would like to congratulate the New Jersey STIC on receiving FHWA's 2022 STIC Excellence Award. Many of you know now that this is our second STIC Excellence Award, and we're very proud of it. I had the privilege of being at AASHTO's Board of Directors meeting back in October when the award was announced by acting FHWA Administrator Stephanie Pollack. And we also had the honor yesterday of being presented with the actual awards by our friend Valeria Remizova from FHWA's New Jersey Division Office, the Deputy Administrator. So Valeria, it was great to see you yesterday, and thank you for presenting us with that award. The New Jersey STIC was recognized for several things: for the creation of its communication plan, for creating a core innovation area for organizational improvement and support, and for creating the position of a full-time innovation coordinator. So thank you, Brandy, for that. I would like to thank everyone for your contributions and support that led to this recognition. It's truly a team effort, and there's a lot of folks that contribute to the success of our STIC. Next, I want to talk a little bit about our CIA teams. If you've been with us before, you know that the New Jersey STIC relies heavily on the core innovation area teams to develop and implement our innovation proposals for STIC. Due to recent vacancies, we had an opportunity to make 2 new appointments to our CIA teams. I would like to welcome Crystal Walker of NJDOT's Division of Human Resources to the CIA team for organizational support and improvement. And also, I'd like to welcome Crystal's new counterpart from FHWA New Jersey's Division's Office, Christopher Page, who will continue the team's work of implementing EDC initiatives such as strategic workforce development and virtual public involvement, as well as any new initiatives that will be assigned from the upcoming EDC Round 7. So let's extend a warm welcome to Crystal and Chris, who will be joining us later this morning during the CIA team updates. We look forward to your participation in our STIC Council. And lastly, a little bit about the upcoming New Jersey caucus for EDC 7. We will shortly be hearing from Helene Roberts from Federal Highway regarding the next round of Everyday Counts innovations. I want to mention that we will be holding our EDC 7 New Jersey caucus on February 22nd, 2023. Many of you are familiar with the caucuses, so please save that date. The New Jersey caucus will follow the EDC 7 virtual summit, where transportation leaders from across the country discuss opportunities to implement the newest innovations that best fit the needs of their respective state DOTs. At the New Jersey caucus, STIC participants will discuss the innovations being considered by New Jersey for the upcoming 2-year cycle and form leadership and technical teams to support implementation of the chosen EDC 7 innovations. Following up on the model of our successful EDC 6 New Jersey caucus from the last cycle, there will be breakout rooms and interactive sessions to ensure the engagement of everyone who attends. We look forward to seeing you there. With that, Brandy, I believe I'm handing it back over to you.
Oh, okay, unless you want to introduce our feature
Oh,
presentation.
I'm sorry. So we have
Sure.
one more slide. Sorry about that. With that, I would like to also welcome our feature presentation for today. We have joining us Jess Mendenhall from project engineer from New Jersey DOT, as well as Rabie, principal engineer from New Jersey DOT, who are going to do a presentation on UHPC for bridge preservation. And they are from our NJDOT Structural Value Solutions Unit. So that would be today's feature presentation. And thank you both for agreeing to join us today.
Thank you, Mike.
Okay,
With that, I believe I'm handing it over to you, Brandy. Thank you.
and with that, I'm going to actually hand it right over to Helene. So go ahead, Helene, with your updates from Federal Highway New Jersey Division.
Okay, everybody. Hello and happy holidays. Brandy, is my slide, did you put the slide in with the EDC? My job here today is to talk to you all about the EDC 7 initiatives and introduce them. I don't know who was on the executive session and who was not last week. Hopefully some of you got to attend for the rollout of EDC 7. So I'll briefly go through the 7, ironically, initiatives that were selected for EDC 7. And if you have questions like, why did we pick these initiatives? What are they? First of all, check out our website, our Innovation Everyday Counts website at FHWA. Just Google Everyday Counts. You'll get to the website. It has more information about all these initiatives. Not a tremendous amount at this time, but we'll hear a lot more in the summit in February. So, and how they were selected through an extremely lengthy and detailed vetting process. With industry, with our headquarters office, involving solicitation of ideas from everybody and anybody, and then whittling down with our headquarters office and working with our partners in industry and AASHTO and everybody else to really nail down a couple of initiatives. We like to focus on from 7 to 10 per round. We want to keep it manageable. So the first one is nighttime visibility for safety, which promotes traffic control devices and properly designed lighting to improve safety for all units. So yes, safety people, you do have an initiative this time. The next one is Next Gen TIM. We've seen TIM in previous rounds. That's incident management. Duh. Had a brain freeze there. Incident management, we've seen this in other rounds of Everyday Counts, and this round is focusing on emerging technologies like emergency vehicle lighting and queue warning solutions to enhance our drivers' safety on the road. So Tim is back So that's that. There's a greenhouse gas assessment and reduction targets in transportation planning. I would imagine that for non-planners, maybe greenhouse gas emissions might be a little bit of a mystery. Transportation is the largest emitter of greenhouse gases in the US. And this one provides resources to help agencies quantify greenhouse gas emissions and set goals to decrease motor vehicle, construction, and life cycle emissions through planning and project development. That is a mouthful. The next one is Epic Squared. Now, I'm not sure I understand why this is squared, but I know that the bridge people, because I was one for a long time, like to put squares on things and exponentials. I'm not sure, but I'm not sure what the square is about, but it's about internally cured concrete, which mitigates shrinkage, cracking, and can extend the service life, particularly of bridge decks and pavements, thinner elements that require better curing. The next one is environmental product declarations, cured concrete. Ah, that's it. The C is squared, not the entire. Okay, thank you, Amy. I get it now. Didn't strike me right away. Environmental product declarations for sustainable project delivery. This is a hot topic, particularly in the pavement and materials area right now. Construction materials have environmental impacts during their life cycle. The environmental product declarations document the impacts of our various materials that we use for projects. This tool helps states quantify carbon emissions and reductions using life cycle assessments for sustainable infrastructure. And you might have seen the climate challenge, which is run out of FHWA's pavement office, which really emphasizes environmental product declarations and life cycle assessment tools. We have a tool called LCA PAVE. So this is definitely an interesting one. At least it's interesting for federal highway. The next one is DB in design build. Disadvantaged business enterprises are generally not adequately addressed in the design build contracting method, and this initiative has new practices to support integration of program requirements to help DBEs better compete for design build projects. Now, we're not really right now using design build in New Jersey, but I understand it's in our future. The next one is strategic workforce development. It's back. And in this one, the demand for highway workers is growing. There are emerging technologies requiring new skills from our workforce, from our people who work on projects. This one helps stakeholders identify, train, and place highway construction workers. And it particularly expands the effort to our rural and tribal community partners to increase their career opportunities on projects. So those are the 7 initiatives that we will be focusing on for EDC 7, which is rolling out with much more detail in February. And that's it for me, I think, Brandy.
Thank you, Helene, and looking forward to that EDC 7 summit in February and the New Jersey caucus to follow. And I'll put those dates up on the screen later, so make sure to put holds on your calendars for that. So next up, we're going to hear from our core innovation area leads. And I'll continue sharing my screen, so just tell me next if I haven't advanced your slide already. But first up is our CIA team of safety. So I'm going to turn it over to Dan and Keith.
Well, good morning, everyone. Happy holidays. Just make sure you can hear me.
Yep.
Awesome.
Yep. Good morning.
So we didn't know when we put these slides together what the ED7 were going to be. So I took a pretty good guess, And today we'd like to highlight a cross-cutting proven safety countermeasure that was just included in EDC 7. So nighttime visibility for safety, which includes retroreflective signage, it includes pavement markings, and it includes roadway lighting. So today we'd like to focus on the lighting aspect because the number of fatal crashes occurring in daylight is about the same that occurs in darkness. However, the nighttime fatality rate is 3 times the daytime rate because only 25% of the vehicle miles traveled occurs at night. So at nighttime, vehicles traveling at higher speeds may not have the ability to stop once a hazard or change in the roadway ahead becomes visible from their headlights. Therefore, lighting can be applied continuously along segments or at spot locations such as intersections and pedestrian crossings in order to reduce the chances of a crash. Next slide, please.
Alrighty, hello everyone. I'll just continue. Adequate lighting at or above minimum acceptable standards is based on research recommending horizontal and vertical illuminance levels to provide safety benefits to all users of the roadway environment. Adequate lighting can also provide benefits in terms of personal security for pedestrians, wheelchair and other mobility device users, bicyclists, and transit users as they travel along and across our roadways. Next.
Next, we're going to highlight a best practice or noteworthy practice from Florida DOT. And let's see if this works, Randy.
Yeah, let me know if you can hear it or if you can't hear it, actually. Okay,
I got a link ready. If we need to, I can share my screen and play it
great.
through
Okay,
YouTube.
let's try it.
And there's no sound.
You have to check the box to share the sound with it.
Yeah, I was looking for that. I think that was Amy chiming in. I was looking for it and I couldn't find it. So if anyone can tell me where it is, or I can turn it over to you, Keith.
Yeah, I'll pull it up on YouTube.
Thank you. Okay, so I'm going to stop sharing and we'll just let Keith take over there.
Always have a plan B.
Yeah.
And a plan C and a plan D. I think Mike said that to me this morning, actually.
Mike knows. Everyone can see the screen.
Yes.
And play. You can hear it?
No.
No, we can't hear.
I think when you share your screen, you have to check that box or it won't pick up the sound. I don't know why, but.
Let me try again. Include computer sound. Thanks for everyone's patience. We're going to try this again.
Yes.
Yes, very good, thank you.
What if you could save lives just by turning on the lights? The fatality rate on our roadways is 3 times higher at night than during the day. The reason is simple: insufficient light. Roadway lighting along segments, at intersections, and pedestrian crossings can improve safety for all roadway users, including drivers, pedestrians, bicyclists, older drivers, and other vulnerable road users. In fact, roadway lighting is proven to reduce nighttime injury crashes on highways by 28%, nighttime intersection crashes by up to 38%, and nighttime pedestrian crashes at intersections by 42%. Florida is just one state realizing the safety benefits of improved lighting.
Florida DOT began implementing LED light installation several years ago. Florida has a unique approach, particularly in focusing on pedestrian crosswalks. While the results of that are still preliminary, LEDs are very new, the early results look very promising.
For instance, LED lighting replaced older high-pressure sodium lighting that was not optimized for intersection crosswalks along the Bush Boulevard corridor near Tampa Bay. Preliminary data show that nighttime injuries and fatalities have been reduced by more than 50%. Since then, hundreds of intersections in the area have been retrofitted with LED lights. The results have been dramatic.
District 7 was able to implement improved lighting at over 400 intersection locations, and before and after studies have shown the crash reduction has been up to 65%.
The answer is not just more lighting, but improved lighting.
LED lights are more efficient at rendering colors. We can choose the exact color temperature that optimizes visibility for drivers, as opposed to previous high-pressure sodium technology was only limited to one color temperature.
In North Florida, FDOT implemented LED lighting at multiple locations with a history of severe nighttime crashes. A project on State Road 30 near Pensacola Bay is a prime example.
It was an enormous amount of crashes all through the corridor. So we felt like that the LEDs was a good option for this particular roadway. 6 years down the road, we find that instead of 14 to 18 deaths, pedestrian and bicyclists along the road, we've come down to 4.
Improved lighting saves lives. Modern technologies and techniques have made improving safety as easy as turning on the lights. Visit the FHWA roadway lighting page to learn more.
Okay.
I will include a link to that roadway lighting page in a couple
Yeah,
seconds here.
Keith, this is Mike. There seems like there's an incredible amount of potential there for improving safety with what would seem to be fairly little effort, you would think, right? I saw Deanna Stockton on earlier, somewhere on here, and we should also have a conversation at the local level with the municipal engineers and the county engineers. We could possibly be addressing this problem using some of our state aid funds through the local aid programs as well. I don't know. My initial reaction is this seems to be some very low-hanging fruit in order to get some very good returns on safety with minimal
Mike,
investment.
thanks for teeing that up for me. I'm actually the vice president of the Municipal Engineers Society next year, and it's my responsibility to set up all of the educational seminars. So we have 4 general membership meetings each year. So definitely would love to work with the STIC on this to bring it to the municipal engineers.
Thank you. I appreciate that. Thanks.
And we could be available for any kind of training or technical guidance or anything you need. So let us know, please.
I'll reach out. Thanks, Keith.
Thank you.
Okay, thank you, Dan and Keith, and thank you everyone for your patience with the video. I know now when I share in the beginning to click that little toggle switch. So, you learn something new every day. There you go. But up next, we have our CIA team of infrastructure preservation. And with that, I'm going to turn it over to Shivani Patel and Nunzio Murla.
Good morning. My name is Shivani Patel, and I will be providing an update on the infrastructure preservation innovations. Since September, the team has continued to recover from the loss of key staff and tend to urgent and fluid departmental needs. Team leadership has decided to implement staff augmentation to help the CAD development and support unit. Staff will be charged with helping the team move forward with digital as-builds. This can begin once the Open Roads Designer and Open Bridge Designer software is up and running. The team will continue to prioritize the advancement, implementation, and full use of the new CAD platform in the next months. In addition, NJDOT staff are continuing to learn about digital as-builds and their extensive benefits in design, construction, and operation. Staff recently participated in the Ignite webinar, where several industry leaders defined digital twins' benefits, drivers, enablers, components, and tools. Staff also partook in the FHWA November Digital As-Builds Forum, which featured a presentation from Building Smart on industry foundation classes and standards. Next slide, please. The digital as-builds innovation is currently in the development stage. Due to the loss of key staff members who have not yet been replaced, the team has not been able to attend to this initiative. However, the team anticipates the implementation of STAG augmentation will lead to progress with Open Roads Designer and Open Bridge Designer software, and then to digital as-builds. The biggest obstacles to the advancement of digital as-built have been staff availability and staff expertise. With so many key positions vacated over the past few months, this initiative has gotten no traction. The team has been advised that staff will be appointed to these key positions once the vacancies are advertised, interviews are completed, and candidates are selected. Although EDC 6 is coming to a close, team leadership has stressed that they will continue to pursue this very important innovation plan. Next slide, please. Okay. The team has submitted the system architecture review documents, which are necessary to obtain an agreement with the company. The SAR is a required multi-phase process that involves OIT and IT staff members. The team is currently holding off on any further action while the SAR is pending. Following the completion of the SAR, the team is hoping to move forward with the procurement process as well as vendor selection. In the next months, the team, along with other internal staff, will begin learning how to use the new system. Next. The e-ticketing innovation is currently in the development stage. The team has been working on and prepared the logical system architecture review documents required to select an e-ticketing vendor and the necessary software. The SAR process paperwork is voluminous and quite time-consuming. This has been identified as a major reason for slowing the progress towards implementation. Ultra-high performance thin overlay, a highly polymer modified asphalt, also known as HEMA, is included in the Route 42 pavement preservation project. The project, which was awarded on June 20th, 2022, is currently in construction. The Route 42 project will be the first HEMA project for NJDOT. Since the last update, skid testing by the Pavement Management Unit was conducted on an additional 6 projects on high friction surface treatment sections. In the next months, the team will continue to closely monitor and analyze the pros and cons of utilizing this type of asphalt mixture on concrete pavements in New Jersey. Based on the results, the team will advise the department on future use of enhanced friction overlay treatments. Additionally, the NJDOT Pavement Management Unit will continue skid testing of high friction surface treatment sections. The targeted overlay pavement solutions innovation is currently in the assessment stage. The Route 42 pavement preservation project, which includes ultra high performance thin overlay, was recently awarded to South State and is currently in construction. The team plans to closely monitor this project to gain further insight on the application of this material. The procurement of new skid testing equipment has been identified as a major accomplishment for the team. They've completed skid testing on a total of 9 projects this year. The NJDOT Pavement Management Unit will continue skid testing on high friction surface treatment sections and alternative enhanced friction overlay sections. Following the completion of testing, they will analyze and monitor skid test results to advise the department on future development and the use of enhanced friction overlay. In addition, Rutgers University will be performing companion testing as part of a pavement support program task. They will test on various friction test sections using a dynamic friction tester. Once mixed design, production, and construction of the UHPTO is underway, the team will observe, assist, and document any issues and lessons. Following the compilation and analysis of all data on the different enhanced friction overlay surfaces, the team will be better able to inform staff within NJDOT and other state agencies and stakeholders on the recommended use and practices with EFOs. The team has identified skid testing equipment function and calibration as being critical to the process of collecting and analyzing the data. The Pavement Management Unit will also continue to explore other test methods in the near future. Next slide, please. Since the last update, the team completed the data collection and reporting for the monitoring and evaluation program that was necessary to establish the baseline of the UHPC overlay bond condition. The baseline testing was successful. No significant defects were found. Periodic monitoring of the UHPC overlaid bridges will continue over the next several years. Recently, the team prepared a research paper and presentation for the 2022 International Accelerated Bridge Construction Conference. The paper and presentation showcases the NJDOT UHPC overlay pilot projects. The team will continue scoping and implementing additional UHPC applications for future projects where opportunities are available. The team is seeking funding and grant opportunities to extend the UHPC overlay monitoring and evaluation program up to the year 2026. Next year's monitoring may be in similar locations or sites of concern. However, the selected sites will be different from the baseline to allow for the maximum area of the overlay to be tested by the end of the monitoring effort. The UHPC for bridge preservation and repair innovation is currently in the assessment stage. There have been several notable accomplishments thus far, including the completion of 2 UHPC overlay projects. In addition, NJDOT's first UHPC Links Lab application is in construction. An additional UHPC overlay and the Links Lab applications are in project design phases. The demonstration of the 2 current pilot projects indicates promising results for further implementation. UHPC has shown to increase service life, but both material and labor is currently more expensive than traditional bridge preservation techniques. The team believes more widespread use and experience may help reduce cost. Industry experience in UHPC applications is limited. UHPC is not standardized for operational use. It is primarily used for repair projects that were not pre-planned. The team has found that there is no consistency in the applied product and there is limited availability of the UHPC repair materials and methods. Also, the material can be quite difficult to work with, and contractors may require training in using such material. Over the year, the team has participated in and presented at several workshops, conferences, and peer exchanges related to this innovation area. NJDOT has also received several technical assistance requests from other transportation agencies, including Caltrans and District Department of Transportation, who are seeking to develop knowledge related to UHPC for bridge preservation and repair. NJDOT will incorporate UHPC for bridge preservation and repair in the new design manual and the new NJDOT guide plates. Additionally, after the current pilot project long-term testing is completed, the data collection and lessons learned will be used to revise special provisions, which requires further investigation, performance data, and the life cycle cost analysis. Next slide, please. Thank you.
Okay, thank you, Shivani. Okay, next, many of you probably heard that Brian Goodson and Zenobia Fields have moved on to new roles. So again, we want to welcome Crystal Walker and Christopher Page to the Organizational Support and Improvement CIA team. Crystal's career began at DOT as a personnel trainee, where she learned about how New Jersey state government operates and more about our agency, the services we provide, and the impact training has on DOT's mission and culture. As her knowledge and her title advanced, she assumed oversight and responsibility of training and other initiatives. Her key responsibilities include overseeing training staff and departmental training liaisons, ensuring equitable distribution of meaningful learning opportunities for all employees, managing DOT's training and employee development budgetary and fiscal funds, facilitating the development, management, and review of divisional workforce development plans, assigning, conducting, and facilitating various trainings for the department, and overseeing the development of agency-specific learning programs. Finally, she functions as the department's LMS fiscal officer, maintaining all training records and researching course needs for individual and unit needs. She is a busy lady. So Crystal, if you want to hop on and just say hi.
Good morning, everyone. Can you hear me okay?
Yep.
Great. Good morning, and thank you for having me. I'm pleased to be here, and thank you for this opportunity. I really look forward to learning so much and working with you all. So I look forward to the future. Thank you again for having me.
Okay, thank you, Crystal. And again, we also have Christopher Page from Federal Highway New Jersey's division office. Prior to joining Federal Highway, Chris worked in community planning roles in the states of California and Arizona. In his current role, he's responsible for carrying out USDOT and Federal Highway's goals and mission by providing oversight and stewardship to NJDOT and other relevant local stakeholders to ensure compliance with appropriate federal regulations. His current programmatic responsibilities include the STIC, NJDOT's State Planning and Research Program, National Electric Vehicle Infrastructure, and the Local Technical Assistance Program. He provides necessary resources and addresses needs as they arise while also coordinating with staff to provide and maintain federal regulatory compliance. So Chris, if you want to hop on and say hi and turn your camera on.
Yeah, can everyone hear me okay?
Yep.
All right, perfect. All right, good morning, everyone. Thanks for having me here. Just, want to echo same thing Crystal said. I'm looking forward to working with you all and immersing myself in the STIC. So again, thank you.
Okay, and so please join me in welcoming Christopher and Crystal. Okay, so next up, we're going to move on to our last CIA team. We're going to get updates from Mobility and Operations. So please welcome Sal Cohen and Ake Pomsavath.
Thanks, Brandy. So good morning, everybody. Couple of details, excuse me, couple of details for our EDC 6 initiatives. One of the things that we had hoped to accomplish, and it's part of our statewide traffic incident management strategic plan, is to be able to connect our real-time TMC data sets with the state police's computer-aided dispatch. We had a glimmer of hope early on where the state police were going to be launching a new platform. They did, and in layman's terms, they don't like it, and so they're going to go back to their old platform, which does not have any kind of interconnectivity. They're going to maintain what they had and kind of see what they want to do. So once they kind of get their ducks in a row, we've gone back and forth on this a couple of times. Once they get their ducks in a row, we'll be looking to do that. It's still part of our strategic plan because right now, when computer-aided dispatch information gets fed in, not every call comes to the DOT. They figure if we don't need DOT, we won't call DOT. But we are on the response for where we have our safety service patrol, where we have our cameras, where we're using Waze and other kinds of probe data to detect incidents. We just want to be able to make that connection between the official state reporting system and what it is we have at our TMCs. Next slide. Look at that picture. Picture.
Good morning, everyone. During the first week of November, Sal, Brandy, and I traveled to Raleigh, North Carolina to participate in the peer exchange. Special thanks to Brandy Chapman for taking time out of her busy schedule to hang out with the operations folks in North Carolina and eating good barbecue as well. State DOT participants included Maryland, Ohio, South Carolina, Tennessee, Vermont, and Washington, D.C. It was an opportunity for each of the state DOT representative to talk about their crowdsource journey, challenge, best practice, and future plans. During the peer exchange, one of the common themes during the workshop was that most of the state DOT agency were procuring the same crowdsourced data from the same vendors. So there was an opportunity to share notes on the procurement practices among the operating agency. There was also a need for workforce planning, especially training on data analysis, a need for a need for data scientists within the operating agency, especially help with reviewing new data sources, big data, forecasting, and trying to make that association patterns and trends that have nexus to the operations program. There will be continued use of crowdsourced data in the operations domain. We are seeing many different use, different application to support origin destination data, truck parking availability, finding different ways of collecting traffic volumes, looking at local street data, inclement weather, data management, and verifying data accuracy of those crowdsourced data. And lastly, supporting connected vehicle. NJDOT is currently institutionalized by deploying the DriveWise truck alert system. It has been operational since January of this year, covering 647 roadway miles. Although EDC 6 is ending and looking ahead, the NJDOT will collaborate with NJIT in the new calendar year to deploy the Haas alert technology on safety service patrol vehicles. The system will alert drivers of stop responder vehicles when responding to incidents on the roadway by way of phone apps like Waze and Apple CarPlay. And this concludes the update for the CIA operations team.
That was very
could
good.
take-
This is
I
Mike.
could-
Can I jump in there with a question, Sal?
Yeah,
What-
and I did have two other pieces I wanted to mention too, Mike.
Okay, go. Well, you finish and then I'll jump in.
So just many of you know, New Jersey DOT is a member of the Eastern Transportation Coalition.
That was my
And,
question.
see, it's right there, Mike, right there all the time. I can see you in the picture having the barbecue too. That's how closely aligned we are. So the Eastern Transportation Coalition has a program called the Transportation Data Marketplace. Transportation Mobility, our group, is the conduit through the University of Maryland and the Eastern Transportation Coalition to purchase a variety of data sets. They just expanded that in July of this past year, and we held a conversation with units from across the department to explore any additional needs that you may have. Now is the time to investigate any type of new data needs, whether it's O&D, map conflation, real-time connected vehicle data. Now's the time to understand what your unit may want to use, either in your existing platform environments or as a part of any existing ongoing programs, because more and more we're getting away from the field-based data sets and moving to the what I'll call the ether, right? The connected vehicles communicating to large-scale cloud-based platforms that can communicate and feed to your systems. So this is the kind of time frame we want to look at, because in June, we will have enacted a new agreement with the University of Maryland to procure systems data we already have. But once we engage that contract, we then have to redo a whole contract if we want to add anybody else. So, Mike, that's what we're doing. Also, as a side note, and Ake, I mentioned this to you, the Traffic Incident Management EDC 7, Paul Joden has asked me to be part of their virtual session to present on New Jersey's DriveWise platform for stop queue notifications, crash notifications, and the like. So New Jersey, once again, joining our partners at FHWA in the national stage.
Thank you, Sal. I appreciate that. Yeah, that's the first thing that came to mind. I was down in Maryland last week with the Coalition for a National Peer Exchange on the mileage-based user fee. And as you were doing your presentation, that's the first thing that came to mind was, what is their regional role in this? It's a perfect fit. Thank you, Sal. Thank you, Ake.
Yes, thank you both. And for the experience at the crowdsourcing peer exchange, it was really interesting to learn about how these peer exchanges are so instrumental in sharing best practices and, sharing lessons learned and institutionalizing these EDC initiatives. So thank you for that, and the good barbecue.
Yeah,
so
and we,
now
we indoctrinated her, Mike. She gets it.
Yeah. So, okay, so I did see a couple hands go up as presentations were happening. I couldn't quite get to them. So if you have questions, just feel free to pop them in the chat so we can monitor that and get to them. But for now, and as usual, we're ahead of schedule. We're going to take a quick break. And you can either get up and take a quick break, or you can hang out for a minute and play a little bit of transportation trivia, and then we'll get right back into it and start our feature presentation. So hang out for a minute if you want to. You can join the trivia by going to this website and use this code. I'll tell you right now that the trivia today is all about EDC, because we're closing out EDC 6 and EDC 7 is right around the corner. And for the quiz, I suggest using your real name instead of the anonymous, so we know who's on the leaderboard, or initials if you don't want people to know, it's okay. You'll have 20 seconds to answer each question. They're multiple choice, but more points are awarded for fast and correct answers. So if you have no idea what an answer is, it's just best to make a quick guess. And I'll give a few more seconds for folks to join, and then we'll get started. Okay, so everyone can see this? Okay, so we're going to go ahead and get started. Looks like we have a good number of participants. Okay. Here we go. You have 20 seconds to answer each one. Which years did the first EDC round cover? 2009, 2010, 2010, 2011, or 2011 to 2012? Okay, the correct answer was 2011 to 2012. Okay, question 2. Which of these EDC 5 innovations is institutionalized in New Jersey? Crowdsourcing for operations, project bundling, safe transportation for every pedestrian, unmanned aerial systems, or all of these? Trick question, it was all of them, and most people got it right, so good job. Okay, so here we have our leaderboard. Let's see who's in the lead. We've got DRH in the lead. Second up is Clippy. DRH is fast, so maybe they're just guessing and kind of putting stuff in, but we got Clippy up close. So let's see. Question 3. And there's 5 questions total. I forgot to mention that. Which of these innovations are from EDC 2, the second round of Everyday Counts? Intelligent compaction, weather savvy roads, or warm mix asphalt? No Googling it. Okay. Most people got it wrong. Intelligent compaction. Okay, question 4. Which innovation was not identified in at least 2 EDC rounds? Safe transportation for every pedestrian, automated traffic signal performance measures, data-driven safety analysis, or geosynthetic reinforced soil integrated bridge systems? It's a mouthful. Okay. And only one person got that right. It was automated traffic signal performance measures. All of the other innovations there were in at least 2 EDC rounds. Okay, we'll see who's in the lead here. Okay, SR with 1782 points, and DRH is still second up, so. Last question. Which innovation was included in previous rounds but is not included in EDC 7? So who was paying attention to Helene when she went over the EDC 7 initiatives? Crowdsourcing for operations, next gen TIM, strategic workforce development. Which one is not in EDC 7? All right, most people got that right. Crowdsourcing for operations. Okay, now we'll see who won. This is who got that question right, adding up points, and who is our winner? The yellow dart. Whoever that is.
That was really hard, Brandy.
Was it? I tried to make it easier. I was like, after last time, I was like, let me make it a little easier. Okay. All right. Well,
Definitely thought I would do better on that. It was really hard.
okay, well, good to know. All right. Well, next time I promise I'll make it easier. So that's going to conclude our transportation trivia for today. And with that, we're going to move right into our feature presentation, which is UHPC for bridge preservation. And for this, we have Jess Mendenhall and Samir Rabie from NJDOT Structural Value Solutions Unit. And they're going to be talking about ultra high performance concrete for bridge preservation. So with that, I'll turn it over to the presenters. And I know you're going to share your screen, so I'm going to stop sharing mine and turn it over to you.
Thanks for the introduction, Brandy.
You're welcome.
I guess you can hear me okay?
Yep.
Yeah, okay. All right. Good morning, everyone. We're going to present on NJDOT's ultra high performance concrete overlay research project. We've done this presentation a few times before, not for the STIC or EDC, but for this version, we're going to emphasize UHPC overlays for bridge preservation and rehabilitation. So we're going to be discussing the project development, design, construction, some lessons learned, and also the post-installed evaluation program of the UHPC overlays. Next slide. Okay, so UHPC has become commonly used in many states throughout the U.S. for joint fill applications or the connections between prefabricated structural components. NJDOT has had a lot of experience with the use of the UHPC in these joint or connection applications for about the past 10 years. And we've had a lot of success with the material. And given its superior properties, we have been investigating the use of UHPC for other applications. So UHPC overlay application was considered after federal highway reporting on successful use at another state agency, and also there's quite an extensive use of UHPC overlays throughout several countries in Europe. UHPC overlays in the US, however, are considered an emerging application. So the focus of this project again was the use of UHPC overlay for preservation of existing bridge decks. And a brief project overview. We had 4 bridges in the project, about 48,000 square feet of deck area, and we had 2 separate construction contracts, a region north and a region south, and we had a separate contractor on each project. And I'll get into more details of the bridges, the specific details on the following slide. Okay, so many of you are probably already familiar with UHPC, but if you're not, I'm going to quickly go over some of the material details. So UHPC is a cementitious composite material. It's typically composed of Portland cement, supplementary cementitious materials, fine aggregates, water, high-strength steel fibers, and a series of chemical admixtures, and a common one is a superplasticizer. And unlike conventional concrete, there's no coarse aggregate. And you can see the image in the upper right that shows kind of the mass or the weight distribution of the typical components comparing conventional concrete and ultra high performance. There's an optimized dry material size gradation, and this allows for particle packing, and this gives it a lot of the superior durability properties. And UHPC has mechanical and durability properties that greatly exceed that of conventional concrete. Some of these properties are the compressive strength. There's an increased tensile strength, and there's also a behavior that you don't see in conventional concrete is a post-cracking tensile strength, and that's from the steel fibers that are distributed in the mix. Again, the durability properties are superior to that of conventional concrete, such as reduced permeability. UHPC for closure pores is formulated to be flowable and self-consolidating, and this can be poured into the joints with little or no vibration. UHPC formulations for overlays, however, are much stiffer, and they're considered a thixotropic material, and they can hold their shape given the grade and the cross slopes on the bridge deck. And you can see the photo in the bottom of the slide showing the self-consolidating mixture on the left and the overlay mixture on the right. And essentially the overlay mixture under static conditions behaves like a solid, but when you agitate the overlay mixture or induce vibration, it flows and behaves more like a liquid. So there's definitely some differences in the workability of the mix. So some of the program background. So traditionally, NJDOT has performed reconstruction of primary bridge components after they become structurally deficient. So that being a deck replacement project or a superstructure replacement or a total replacement project. So if we look at bridge preservation, this will allow us to preserve existing bridge components that are in fair or good condition and extend their service life with a more minimal investment. When it comes to deck slab preservation, we have used various traditional or conventional overlays throughout the years, and we've had some mixed results with this with regard to the construction quality and also the long-term durability. So we've used asphalt overlays with waterproofing, bridge deck waterproof surface course, and also some conventional concrete overlay materials. The photo on the right is a conventional concrete overlay that's been installed on one of our bridge decks. It has nearly 40 years in service, which is impressive for an overlay. But you'll notice in the photo, the overlay is spalling down to the underlying deck, and there's also a deck patch. So this particular bridge deck has been patched extensively over its service life. And considering traffic control and having a contractor come out to do this type of work, there's been an extensive long-term maintenance cost. And with the UHPC overlay, this is hopefully something that could be avoided. We can reduce the long-term maintenance costs. We have over 2,000 state-owned bridges in New Jersey, and as many of these bridges are aging and becoming structurally deficient, the department can really become inundated with costly reconstruction projects. So we do think it's important to put a focus on bridge preservation and try to take bridges that are still in decent shape and preserve, the primary components to avoid, being inundated with reconstruction. Some of the advantages of UHPC overlay, as we discussed, it has superior mechanical and durability properties, which a lot of these properties are ideal for a bridge deck, which has really severe exposure conditions of all the bridge components. Also, the service life, we anticipate a high service life of the UHPC overlay. And looking at the initial construction costs are higher, but we anticipate there may be a life cycle cost benefit, and we'll discuss that on a following slide. Some of the disadvantages, the cost of the overlay is high compared to conventional overlays. So for this project, we had an average cost of the overlay material itself of about $30 to $45 per square foot. And if we look at the total project costs, including traffic control and the roadway work and some of the additional bridge work, we had a cost of about $90 to $120 per square foot, which this cost is still less than the typical deck replacement project, but still much higher than conventional overlays. Also, there's a consideration of the contractor experience. So our prime contractors don't have experience with UHPC in the overlay application. They do have experience using UHPC enclosure pours. However, there are specialty UHPC subcontractors that will have this experience. Also, workability of the mix. It's not necessarily a disadvantage, but it is something that needs to be considered. The overlay mixture may require specialty equipment and has slower finishing rates than other overlays. Okay, so now we want to talk a little bit about comparing deck preservation using a UHPC overlay versus, deck reconstruction or a deck replacement. So some things you want to consider, one is the existing conditions and the remaining service life of the structural components, that being the deck slab and the superstructure and the substructure. So if you're using a UHPC overlay, you anticipate a long service life, and you want to ensure that these other components will be able to be maintained for the life of the overlay. Otherwise, you're not using the investment into the UHPC overlay optimally. You also want to do a remaining service life determination of the structural components, considering their age, doing hands-on inspections, potentially non-destructive testing or evaluation. And also you can do concrete core testing of concrete components and get an estimate of the remaining service life from lab testing. You want to consider the initial cost and the life cycle costs and compare different alternatives, including preservation, rehabilitation, and also reconstruction alternatives. And looking at the typical decision process, so you would look to rehabilitate or preserve a deck that is generally in fair or better condition. And you would look to replace a deck that is considered to be in poor condition, and it may be extensively contaminated or deteriorated throughout the depth of the deck. So I get a target bridge would be a remaining service life. If you're gonna rehabilitate the deck slab for a UHPC overlay, we would anticipate approximately 40-year service life, and you want to make sure that the superstructure and the substructure remaining service life with or without rehabilitation will be comparable. Okay, so an example of a life cycle cost analysis, a general example. So if we look at a bridge that was constructed in 1990, approximately 8,000 square feet of deck area, and kind of a typical highway bridge, single span multi-girder bridge, some of the assumptions that we could look at is, okay, overall, all the structural components are in fair condition. We're going to assume that we're going to do repairs to the superstructure and the substructure for either alternative to increase the remaining service life. Assume a 40-year service life of the UHPC overlay, and then only for this cost comparison, we're going to look at structural costs only and consider that we're going to do routine maintenance on the bridge. So the first alternative would be to do a UHPC overlay now. The bridge is in fair condition, so we can consider a UHPC overlay and rehab the other components. And the second alternative would be to do nothing now and replace the deck in, say 10 years, when we'll assume that the bridge will drop into a poor condition. So the alternative two is kind of our typical thought process that we use. We move in to do a reconstruction when the bridge becomes structurally deficient. So those are the two alternatives that we're going to consider. So we did a cost analysis and a life cycle cost analysis for this example bridge. So looking at the initial construction cost, the UHPC overlay for doing the deck work only is approximately $480,000 to $500,000. If we were to do a deck replacement based on cost of other comparable projects, we would be looking at, for this bridge, approximately 1.1 million. For this is for the initial construction cost. Now, over the life cycle cost over a 100-year analysis period, for the UHPC overlay alternative, we have a 100-year life cycle cost of 7.2 million. And for the deck replacement alternative, a life cycle cost of 7.7 million. So initial construction costs, it's relatively significant cost difference favoring the UHPC overlay. The 100-year life cycle cost, clearly the UHPC overlay has a lower life cycle cost. And we use some conservative assumptions. So, with a life cycle cost, it's heavily based on the assumptions that you make. So potentially this could be an increased savings or a decreased savings depending on those assumptions. So I don't want to focus too much on the exact numbers on this slide, but I guess we're just trying to emphasize to, do an analysis of the initial construction costs and also look at a life cycle cost analysis to compare preservation versus reconstruction projects. Okay, so back to some of the details of our research project. I'm going to talk a little bit about the bridge selection process that we used during the project development. And these are 4 photos of the bridges that were ultimately included in the project. So during the project development, we screened dozens of bridges. Eight structures were shortlisted and they were fully evaluated and tested. And I'll talk a little bit more about that evaluation on a following slide. 4 structures were advanced into the design and construction. So some of the considerations for the candidate bridges, looking at the condition ratings of the primary structural components, we were looking for bridges that were in fair or good condition ratings. And, kind of repeating some of what I mentioned before, we wanted to ensure there was adequate remaining service life of the structure. We were looking for decks that didn't have signs of extensive deterioration, no underdeck spalling or chloride contamination. And for this research project, we wanted to keep the scope of the work to the overlay and avoid having to do extensive repairs to the other components. The focus of the project was on the UHPC overlay. So all bridges that were ultimately selected had an existing asphalt overlay, and we wanted to avoid decks that had an extensive depth of this overlay. Another consideration, given the high anticipated service life of UHPC, we want to ensure that the bridge will be functionally adequate for the long term. So looking at things such as load ratings, the parapets and the safety features, and the roadway widths and clearances, you're going to want to make sure that those are going to be acceptable in the long term, and you're not going to have to come back in after installing a UHPC overlay and do a widening or reconstruction and get the most for the investment. Some reasons bridges were eliminated. After doing evaluation, we determined there was extensive deck chloride content. And also the traffic impacts. This was a staged construction job. So if taking a long-term lane closure was something that was deemed to be, unacceptable or we wanted to avoid for the research project, that was another reason some bridges were eliminated. Okay, so this is a table of the 4 bridges that were included in the contract. Some things to note, we had 2 bridges with decks that were relatively new, approximately 10 years in age, and we also had 2 bridges with deck slabs that were approximately 30 to 40 years in age and towards the end of anticipated service life. We had a range in the deck slab areas. Again, all bridges had existing asphalt overlay, and the condition ratings of all of the primary components were good or better. So to talk a little bit about the evaluation that we did on the 8 candidate bridges, we took concrete cores on the bridge decks. We did 3 cores on each bridge deck, and this was to get an accurate estimate of the existing overlay thickness, and also take chloride profiles at various levels through the deck, and this was done with chloride lab testing. We also used GPR, ground penetrating radar, to ascertain the overall condition of the deck and get an idea of if there's any variations in the overlay thicknesses, and also to get an estimate after doing the hydro demolition if there's going to be any areas that may require full depth spall repairs. So I'm going to go over some of the key aspects of the design. For this project, we had some environmental constraints. It was a limited scope project, and one of our constraints was to match the existing and proposed elevations. So, as I mentioned before, all of these bridges were asphalt overlaid, so we had to consider options to maintain the final top of deck grade, but also avoid excessive thicknesses of the UHPC overlay. So for this project, we used a thin bonded UHPC overlay. Based on FHWA research, the UHPC overlays can be a minimum of 1 inch, but for this project, we use an average of about 1.5 inches to account for construction tolerances. The structures that had an existing asphalt overlay that was greater than 3 inches were designed with a 1.5 inch UHPC overlay with an asphalt topping. Again, to minimize the UHPC quantities while maintaining the grades. One of the bridges, the NJ159 bridge, was designed with a 2.5 inch UHPC overlay with no asphalt topping. Asphalt topping on top of UHPC overlays is common practice in Europe. And another key aspect of this project, we did not rely on the strength provided by UHPC. It was solely for durability properties, but that's something that we are going to consider for future projects. Okay, so after the existing overlays were removed on the bridges, we specified a hydro demolition to remove the upper 1/2 inch of the existing deck surface. Based on FHWA research and reporting, hydro demolition is the preferred choice for surface preparation for the bridge deck to bond with the UHPC overlay. It creates an ideal bonding surface that's very rough and limited microfractures that can really affect the bond performance. Now, looking at other technologies such as diamond grinding or milling, they can be used, but they do induce microfractures, and that can affect the long-term performance and bond of the overlay. So for this project and for future projects, we're going to specify hydro demolition. And you can see the photo here of a typical concrete surface after hydro demolition. It's a very rough surface. You have exposed aggregates, and it also removes deteriorated areas of the deck slab. So as I mentioned before, this overlay was installed in 2 stages for all bridges. So a stage line construction joint was used to combine the stage 1 and stage 2 overlay. The joint detail that you see on the screen was used in our project and was developed from a European standard and provides detailing to prevent water intrusion and also provide structural continuity in the deck slab. An exposed fiber finish was specified between stage 1 and stage 2 overlay to promote bonding. And previous research has shown that a poor bond between the hardened UHPC in stage 1 and the fresh UHPC in the stage 2, you get a poor bond unless you provide an exposed aggregate finish. So on a following slide, Samer will be showing you a photo of this construction section. So for the deck joints, some of the deck joints on the project, so essentially the end of the deck slab and the abutment header, were removed full depth and reconstructed the full depth with UHPC. From our past experience, this location of the bridge is particularly susceptible to deterioration and spalling, so we wanted to reinforce the area with UHPC. And Samer will discuss some of the lessons learned on this particular detail later in the presentation. So that's it for my part of the presentation. Now I'm going to pass it off to Samer, and he's going to finish the presentation. Thank you.
All right, thank you, Jess. I'm Rabie. Good morning again, everyone. And for the remainder of the slides, we'll cover the special provisions, the construction, the lessons learned, and the evaluation program. Starting with the material testing, the UHPC mixes consisted of a partial premix made by the supplier, including sand, water, liquid admixtures, and steel fibers at 3.25% of the total dry volume. The results of the acceptance test shown on the slides were provided in a submittal package. Due to the global pandemic at the time of testing and verification, there were no feasible labs for this project at the time of construction to provide some of the certified tests from FHWA publications. Meeting the acceptance criteria while having this challenge led to the acceptance of alternative test methods pursued by the supplier, including the bond strength by pull-off and direct tension tests. To ensure the consistency of each batch, a procedure of flow testing in accordance to ASTM C1437 was followed. For fresh properties, the dynamic flow test is measured by dropping the flow table 20 times continuously over a period of 10 seconds, and the average is recorded. With 3.25% steel fibers, the values of the static and dynamic flows were 4 to 6 inches and 6 to 8 inches, respectively. Overlay material is often challenging to control for contractors, regardless of what the material is used. Per the contract document, contractors were required to successfully place a 4-foot by 12-foot by 3-inch deep rectangular test slab of UHPC with a grade of 8% in the longitudinal direction. While this may not be appropriate or necessary for all sites, it should be considered to account for specific project needs, such as the profile grade, cross slopes, and complex geometric conditions related to large skew angles. In the images here, supplier X on the left failed to pass the mock-up test. Subsequently, the contractor invited supplier Y. The actual placement of the UHPC overlay does not require high level of skill, and the placement and finishing skills should be confirmed, attained, or fine-tuned during the mock-up test. Hydromilling was used to remove 1/2 inch of the top of the existing concrete decks, as well as the full depth removal of the existing headers. This provides a rough profile for the UHPC to bond to, removes surfaces exposed to the vehicles and asphalt oils, and also protects reinforcement in the deck in the event it is encountered shallower than anticipated. Hydro demolition spoils and water are required to be hauled off-site to a treatment facility unless permits are obtained for a project for alternative disposal methods. Disposal to public sewage or drainage facilities is strictly forbidden. Specifications should clarify that the cost for any disposal of demolition material must be included in the bid price of the demolition pay item. A specialized contractor brings in prior experience placing UHPC, has established relationships with the UHPC suppliers, and has specialized equipment. A specialized UHPC placement contractor was used as a subcontractor to the general contractor, part of Contract A in Region North, but not for Contract B in Region South. More contractors are expected to join this industry, allowing more competition and competitive bid pricing. To the extent that a specialized UHPC paver is desired or needed, the specialized UHPC pavers are available for purchase by any contractor. This may be the case for overlay thicknesses greater than 2 inches. As long as the documents require the appropriate measures be taken by the contractor, along with the quality control requirements, The desired end product should be attainable by a general contractor or a specialized subcontractor. One thing we'd like to point out about this video is how the operation is maintained and it's continuing while there's traffic on the adjacent lanes, and how it helps with the staging without major impact to the flow. This is the 295 bridge. The contractor should provide how the screed will be set up, and achieve the required UHPC thicknesses to avoid potential thicker areas. Sorry. While the designer shouldn't dictate the means and methods, it may be prudent to include an advisory note that high shear capacity mixers may be needed and should be considered while developing installation procedures. However, it is ultimately the contractor's means and methods to achieve the desired final results. The most crucial element is the mixing and establishing the correct amount of UHPC fluidity to ensure the UHPC holds the grade of the deck. This, however, will always be under the control of the UHPC supplier's experienced technicians, regardless of the presence of a specialty contractor. Exposed fiber finish at the construction joints should be emphasized in the contract drawings by requiring the exposed fiber finish work procedures be included in the work plan and must be submitted before the UHPC work starts. This includes the time for any fiber exposure work to be performed, since in one instance this activity was delayed too long and the UHPC had gained most of its strength. An image of the desired surface should be included in the special provisions or the plans to help reduce any confusion. The contractor's work plan should also include procedure for installing key joint formwork early in the preparation of the construction joints and the stage line construction. Special provisions also require that all formwork in the UHPC must be non-absorbent, which can be achieved by using resin-coated products or wrapping formwork in plastic sheeting. With the mock-up tests and the shop drawings, the contractor should be required to identify the system and demonstrate how the sheeting will be secured if required. The consequences of an insecure system will not only compromise the final product, but could also result in safety concerns to the traffic on the adjacent lane. It is crucial to ensure proper curing in accordance with the specs and approved working drawing procedures to prevent dehydration cracks. Moving on to some of the lessons learned, starting with the scoping and concept development for future projects, we will identify locations that UHPC will serve as the final riding surface. This will allow for evaluation, inspection, and assigning more representative condition ratings in the future. If, however, an overlay on top of the UHPC must be provided for any reason, such as geometry or profile, we will consider the bridge deck waterproofing surface course, which is a performance spec, it's non-proprietary, and it does not require a waterproofing membrane. Another alternative could be the high-performance thin overlay materials. For the existing conditions, GPR can help determine concrete cover, overlay thicknesses, and reinforcement locations, as well as locate emerging spalls or delamination. This will help attain more accurate bids based on the deck repair limits. Two other items we are improving in our special provisions are additional language that during construction there should be emphasis on surveys for each interim stage to determine the actual depths of the hydro demolition and the material quantities required for placement to ensure a continuous operation. The other item would be emphasis on specifying watertight forms, top forms, and the minimum of 1/4 to 1/2 inch overfill to help reduce the amount of surface deficiencies. The contractor is responsible for determining the appropriate overpool thickness. This could result in higher bids, but additional material quantities are not expected to result in substantial cost impacts. After observing the difficulties of the header demolition and construction, we have two alternatives moving forward. Using the flowable self-leveling UHPC for the full depth of the header placement to ensure proper consolidation around tight corners and reinforcement. The other alternative is a hybrid system of partial depth, high-performance concrete headers with UHPC over the top surface to provide the same overlay thickness over the entire structure. This will help mitigate some constraints and staging and schedule allowance. 2 of the 4 bridges in both contracts experienced air voids or dehydration cracks or shrinkage cracks, which we are collectively referring to as surface defects, as shown on the image on the right. The UHPC slurry with no fibers was placed in the identified air voids. Since the voids contained overlapping exposed fibers, it was considered to create adequate bonding with the UHPC slurry. All the surface defects were addressed before asphalt paving, except for one structure where the UHPC overlay serves as the final riding surface. Out of an abundance of caution, these locations were identified for future monitoring. Also, these cracks were not observed when the sheeting was properly installed and secured, as shown on the image in the center. So for the evaluation program to assess the performance of the UHPC overlay, we put together a testing program to include non-destructive testing as well as physical sampling and lab testing. This objective will be accomplished by first establishing baseline conditions through an initial survey, followed by periodic monitoring of the UHPC overlaid bridges over succeeding years. This will give us some understanding of the deterioration rates, which will be beneficial in determining the life cycle cost analysis, as just discussed, during decision-making and alternative selection. Sorry. The 2 bridges that were selected was the 295 bridge with the asphalt overlay on top of the UHPC, and the 159 bridge westbound, which had the UHPC exposed surface. For the non-destructive testing, we first looked at GPR, which was used. However, the GPR signal was scattered significantly, and the 3D rendering was ineffective due to the presence of the steel fibers in a random configuration in the concrete. So we moved to the impact echo and ultrasonic shear wave tomography. For physical sampling, we used the pull-off strength to give us the pull-off testing to give us the bond strength, and more importantly, the failure modes. Also, we did the chloride content to understand the permeability. This is a sample plan sheet. Most of these locations were either identified during construction, or they are areas of interest to our unit, which are at the construction joint or the negative moment region in the case of this bridge. During an impact echo test, the surface of the concrete is impacted to generate stress waves. The response signals, when analyzed, include a range of frequencies corresponding to the element thicknesses, reinforcement, delamination, and geometric boundaries. The impact echo testing was applied on a point-wide basis over a 2-foot by 2-foot grid at various locations along the bridge. On the graph shown, the horizontal axis shows the distance from the beginning of the grid, increasing towards the east, and the vertical axis shows the dominant frequency in kilohertz. In most cases, the dominant frequency was approximately 6 kilohertz, with the exception of 2 lines. With this line being clear at this area at 6 kilohertz, this gives us an indication that the bond between the asphalt overlay and the UHPC is intact, as well as the bond between the UHPC overlay and the substrate or existing concrete. At 2 locations, we were not able to get that dominant frequency, giving us an indication that there might be delamination or debonding at these areas. These areas were identified and were included in the succeeding year testing program. Shear wave tomography involves the propagation of shear stress waves, or S waves, through the concrete, transmitted and received by an array of transducers. Analysis of the signal times and angles allows for the construction of a 3D representation of embedded features. The transducers are spring-loaded, allowing for the testing of uneven surfaces, unlike the impact echo. So for the 159 bridge with the exposed deck, we were not able to perform the impact echo test because the width of the grooves on the deck corresponded to the dimensions of the impactor. That's why we moved to the ultrasonic shear wave tomography. This data was collected on a grid as well at 6 inches by 4 inches to construct the 3D representation, and the test sections were used to complement the impact echo findings for the 295 bridge. The data is collected at a series of shots, step by step, on a grid. The asphalt concrete bond appears to be sound, therefore the reinforcing bars are clear, as we can see here. There were no further discontinuities observed below this depth, indicating an intact bond between the original concrete deck and the new UHPC overlay. The non-structural bond between the asphalt layer and the concrete was weak at a few locations, blocking the majority of the signals, as we can see over here, where this reinforcement is masked as compared to the one next to it. And these areas were also marked and identified for the succeeding program. The table on the left is showing the results from the pull-off testing. There are 4 modes of failure. Failure mode A, which is at the substrate. Failure mode B, which is at the concrete interface. Failure mode C, which is within the overlay. And failure mode D, which is at the epoxy interface. At the beginning, most of the failures were for failure mode D for us until we nailed down the epoxy that we need to use, as well as the curing times. After which we got the desired results of failure mode A, except for a few locations where we got failure mode C, and those areas were also identified. For the chloride contents, the segments were taken at 2 depths, at 1/2 inch, which is within the UHPC overlay, and 1 inch, which is below the UHPC overlay. Generally, the chloride contents were considerably lower than the 2 pounds per cubic yard threshold to initiate corrosion per our NJDOT bridge design manual, except for core C2, which had very high concentrations of chloride. Potential cause for C2's unexpected high chloride content may be due to the area from which it was extracted. Properties such as the location, geometry, condition, to name a few, may have led to the pooling of water or salt water within the area of core C2. Finally, to conclude, the ultrasonic shear wave thermography and impact echo testing indicated that the bond between the UHPC and the concrete substrate is in fact intact. Bond strength test data demonstrates that the desired bond was achieved between the UHPC and the substrate concrete. Chloride content, for the most part, were also within expectations. The baseline testing was successful with no significant defects encountered. For future monitoring at the same locations as well as other locations to maximize the testing area. And NJDOT is considering installing UHPC overlays on newly constructed decks, as well as decks with lower condition ratings for future projects. A deeper overlay with deeper existing deck removal will be regarded as a viable alternative for the structures that need major deck rehabilitation. Finally, we are incorporating UHPC for several applications in the new design manual, including preservation and repair. And through our bridge resource program, we're also working with universities to produce non-proprietary, locally sourced UHPC to drive down the cost and increase the applications. Finally, we'd like to thank all the teams that helped materialize this project. Thank you for the STIC folks for inviting us to give this presentation. I will be happy to take any questions.
Thank you, Jess and Samer. If there's any questions, we'll just give a few seconds for people to ask. I think I saw a few things pop up in the chat, but I don't know if they were answered or not. So just take a look in there and see if there's anything. But otherwise, people can just go ahead and ask any questions of the presenters.
Okay, so one of the questions here from Ali, what is the approximate service life of the UHPC overlay? You know, we considered about a 40-year service life for the life cycle cost analysis. I think it's highly dependent on the looking at the, if you're using it for preservation, looking at the underlying deck and, you know, ensuring that you know, if you put the UHPC overlay and it should prevent further chloride ingress or moisture ingress. So even if you have already have chloride contamination or corrosion issues, those we anticipate that those would cease. But if you have a deck slab that doesn't have those issues, it's not extensively chloride contaminated, the overlay is going to really cut off those contaminants. So, you know, realistically, we think we could get more than 40 years out of it. But, you know, other components of the bridge are going to deteriorate, and they're going to require replacement, or the bridge will be functionally obsolete. And we think that that's ultimately what's going to limit the service life. I mean, these materials and testing, they have some UHPC samples that FHWA has tested since the 90s and had them essentially ponded in chloride baths, and there's been no, you know, essentially no deterioration detected. I mean, it's really an impermeable material. But yeah, for our analysis, we considered about 40 years. And the second part of that question, what is the surface preparation? You know, I know we covered that. Hydro demolition is what's recommended. It provides a, you know, superior bonding surface. And a big thing is when you're demoing a deck, it removes all unsound concrete. So, you know, you don't want any unsound concrete interfacing with the overlay material, and you want to have the adequate bond. So hydro demolition is what we used, and that's what's recommended for future projects.
Okay, and any other questions for our presenters?
And then there's another question from Ali. Could you discuss the tension contribution of UHPC overlay to the deck in the negative moment region? So UHPC, it has a much larger tensile resistance than standard concrete. So standard concrete for design, it's normally, the tensile resistance is normally disregarded. UHPC, I think you can get up to maybe 700 PSI before it starts cracking. And then when it begins to crack, the steel fibers take over, and then there's even an increase in the tensile resistance after post cracking. And that's not something we considered for this project. There are draft design guidance that AASHTO and FHWA are working on. They're not published yet, but you can, if you have the adequate interface bond, you could rely on UHPC for tensile capacity, and that's something that we could probably do in a future project if we wanted to strengthen the deck, or if we put the overlay in on a new deck slab and wanted to rely on that for the deck capacity. So there are draft design procedures for that. And I guess in short, conventional concrete, you would ignore any tensile resistance, but UHPC, that could be relied on in the design.
And I can add to that this is also one of the objectives of the evaluation program, is to understand the deterioration rates. We haven't, there isn't a publication, for example, of this in an existing condition, in a site condition outside of a controlled lab environment. So this is also one of the drivers for the evaluation program that we're also seeking funding to maintain throughout 2026.
Okay, thank you both so much. And you know, I'm sure if there's any other questions that come to mind, you could pop them in the chat, or we can provide some contact information for Jess and Samir, and we can pass that on. So I'm gonna share my screen again if Jess or Samir, there we go. Okay, and just before everyone hops off, we have some quick reminders and announcements. First, we're happy to report that in addition to the STIC Excellence Award, NJDOT was a winner of 2022 America's Transportation Award for Best Use of Technology and Innovation. As you may recall from Mobility and Ops CIA team updates or presentations in the past, the New Jersey DOT uses crowdsourced data to deliver real-time information to commercial vehicle operators to increase highway safety and efficiency. The agency alerts drivers to road conditions through a cell phone app or electronic logging device. And the advanced warning of sudden slowdowns or congestion gives commercial drivers more opportunity to slow their speed or seek alternate routes, which helps improve safety for all drivers in the area. So congratulations to NJDOT Mobility. And getting back to reminders, as always, don't forget about our tech transfer website and the dedicated STIC page where you can find all of our STIC business articles and meeting recordings and summaries from prior meetings. And here is your reminder to save the dates for the EDC 7 Virtual Summit, which is taking place from February 14th to the 16th, and New Jersey's EDC 7 Caucus is taking place on February 22nd from 10 a.m. to 12 p.m. So it's the week after the National Virtual Summit, and more information and meeting links will be coming soon, but for now, please put these holds on your calendars. And as a reminder, we have STIC incentive funding on the table. We get $100,000 a year, and we ask that all of our STIC network members work to push these grant opportunities through your networks. Local public agencies are eligible to apply, and it would be great to get some applications from new sponsors. So the link here has all the resources you need to get started, but if you have any questions about the program, please feel free to contact me at any time. So that's going to be it for me. So I'll say happy holidays and turn it over to Mike for final comments.
Thank you,
everyone.
Brandy. So, I might be a little bit prejudiced in my opinion on this, but there's no doubt in my mind why this group is acknowledged by Federal Highway with the STIC Excellence Award. I want to thank not just Brandy and Helene for their leadership, and Amanda as well, in moving this program forward, but I also want to thank each and every one of the presenters today, Keith and Dan and Shivani, Sal, Ake, Jess, Samir. You all did an excellent job. The CIA teams, to a large extent, are the backbone of this program, and I thank you for your continued involvement in this. I appreciate everything that goes into this. So with that, I would just like to wish everybody on this call a happy and safe holiday season, and we will see you, I hope, at the New Jersey caucus, right? So everybody stay safe, enjoy your holidays. Thank you for participating today. Take care.